So as David said, we're going to talk some about what's going on with climate at the moment. And let's just start. There we go. Okay. So keep in mind as we have these conversations today that that's us right there. That little blue dot is Earth. And that's all we have to work with. That's the only place in the universe that can support us. And so it would behoove us, I think, to sort of take care of it. As David said, we've got this issue of disconnect at the moment, where we're not really thinking in terms of Earth. I asked several people the last few days, where are you from? And people told me city names or street names or things like that. Nobody was from Earth, okay? Everybody is from Earth, but it's not in our consciousness, and so we don't use that reference in how we make decisions, which is why, as of 20 minutes ago, we've been able to put up into the atmosphere so far this year 5.8 billion tons of carbon dioxide. We put out in the environment 1.5 million tons of toxic chemicals, and we had altered over 9 million acres of land from something that was verdant and supportive of life to things that had been eroded and deforested, because we just don't think in those terms of what's going on and where are we. So it's important to keep in mind, again, that there's only one planet Earth, and we share it. We're all on it, and we're all in this stuff together. So the question becomes, where sort of are we at the moment? 2019 was the second hottest year, as this graphic shows. This past January has been the hottest January that's ever been recorded by people. There have been hotter Januaries, I'm sure, but people weren't here. We've only been around for the last couple 100,000 years, and so our frame of reference is relatively shallow. Right now, at the end of January, we had 413.4 parts per million of carbon dioxide in the atmosphere. That's just a number. We'll put it in context here in a few minutes. But as you can see, over the last several years, just doing these by leap years, we are on a constantly increasing projection of how much carbon dioxide we put into the air each year. Even though we signed the Paris Accords here, we signed them in 2015, they became official in 2016. Ever since then, we have simply just increased the amount of carbon dioxide in the air. And so we're nowhere close to keeping in alignment with the promises that were made at that particular junction. And to show you where we're going, at the current rate at which we're putting carbon dioxide in the atmosphere, we should hit somewhere around 550 parts per million by 2050. Which is a fairly unsurvivable number. And the other thing to keep in mind is that our evolution happened in this lower phase here. As humans evolved, we were down in the 160 to 280 parts per million of carbon dioxide. And so we were operating way out of our safety zone, way out of our evolutionary zone. Okay? So the real reason for climate change at the moment, physical reason, is all the greenhouse gases we're putting into the atmosphere. And as they interact, as they trap heat and cause changes to happen, that's where we see things like global warming, climate change, ocean acidification, sea level rise, all those other events. Now, people have talked about the fact that the world has heated and cooled over time, and that's quite true. This is the chart that most people look at between when we have no ice and when we have lots of ice. And so the issue becomes, how did those cycles occur? And most of those were natural. Those warm phases and cold phases are about how the Earth orbits the sun. How close is it to the sun? And when we have a more circular orbit, things heat up. When we have a more elongated orbit, things cool down. And that has been the triggering mechanism. But now, we become the triggering mechanism. And when I say we, I mean us. It's humans that are doing this. And so we know that it is, in fact, humans that are doing this, and we can show that in two ways. One is by the type of carbon dioxide that's going into the atmosphere, and the other is the global warming potential of some of the gases that we're putting into the atmosphere. There are three naturally occurring isotopes of carbon: carbon-12, carbon-13, carbon-14. The difference between them is how many neutrons they have. Just a refresher for science class, you remember those days. And it turns out that in the atmosphere, in the physical world, carbon-12, carbon-13 used interchangeably. It doesn't matter. In the living world, things prefer carbon-12. They prefer the lighter isotope. Okay? And so fossil fuels were, of course, at one point, living plants, living algae. And so they have a much higher concentration of carbon-12 in them than you would normally find in the atmosphere. And so as we burn fossil fuels, we are releasing that carbon-12 at a higher percentage. And so this isn't about what's happening just Earth-wise. This is about we have taken sequestered carbon, are burning it, and putting it into the atmosphere. And we know that because of the shift in the ratio of how much carbon-13 there is to how much carbon-12 there is. The other issue that pops up when dealing with climate change is global warming potential. How much heat can a particular gas trap? And what we want to keep in mind is that there are sort of four major groups of gases that we're concerned with. The one that gets all the press, the one that's been the sort of famous poster child of this, is carbon dioxide. And it's famous poster child because it's basically the one we release the most of at this point. Okay? And it has a global warming potential of 1. So of all the gases, it is the least dangerous in terms of how much heating it can cause. Okay? Methane has about 25 times the global heating potential of carbon dioxide. Nitrous oxide, which we're getting out of fertilizers and the burning of fossil fuels, is about 310 times more heat trapping than the carbon dioxide is. And the last group is a group of synthetic compounds, and these are the fluorinated gases. And the big one is the sulfur hexafluoride, which is used a lot in long-distance electrical transmission. Okay? And the problem with this one is that it is 23,800 times greater potential for trapping heat than carbon dioxide is. 2.2 pounds of this gas traps as much heat as almost 26 tons of carbon dioxide. And these are synthetic gases, and so the only way they get to the atmosphere is we make them and release them. As another little prop here, this is an inhaler, and this particular type happens to use a synthetic gas as its propellant, which is also a greenhouse gas. And so this little inhaler, when it gets used, releases into the atmosphere as much heat warming capture capability as burning a tank of gasoline. Okay? And so the issue when we're talking about what we want to do with climate change, we really have to look at all the issues that are involved, not just the ones that are most common to us. Which is why in this work, they're sometimes referred to as a CO2 equivalent. That's this higher number up here. And that is where we take all of the greenhouse gases and look at their combined impact on the environment and how fast that's causing things to heat up. So the other thing to keep in mind if you're trying to track some of this stuff on your own is you have to be very careful what the data source is that you're using. Now, you're fairly safe not looking at US sources. Because most of them don't exist anymore. I was in prepping for this. I was looking at some things, and some of the sites haven't been updated for 2.5 years. So you have to look farther abroad. But the issue becomes what is being reported. And so one of the numbers you'll see more frequently is the upper one, the 36.8 gigatons. This is about fossil fuels. Okay, the carbon dioxide from fossil fuels. What we're really interested in is what is all the carbon dioxide that's making it into the environment. And so whether or not that is from using carbon dioxide in electricity or transportation, it's also about the stuff that is made from cement, and it's about the areas that we have changed that can't absorb carbon dioxide anymore. We've taken away the sinks where we used to store carbon dioxide, and that stuff is gone. And so if you look at the combined total last year, it was 43.1 gigatons. Okay? Now, gigatons means nothing to anybody in this audience, doesn't mean anything to anybody in the world. And so what I've done for you is I've translated this into elephants. Okay? Average African elephant, you take young ones and old ones and males and females, average out around 4 tons. Okay? So to get 43.1 gigatons of carbon dioxide into the air is the equivalent of launching 342 elephants into the air every second. Okay? And if you saw that, you would ask questions. You know you would. You know, is this a good idea? You know, who thought it was a good idea? But because CO2 is odorless, colorless, tasteless, we don't have that conversation. Okay? This is the conversation we need to have. And then when you find out that those elephants are just accumulating over your head for the next decades to thousands of years, you know, then you're really going to get some concern in this matter, which is really what we actually need. And so we put a lot of the CO2 up in the air, you know, through traffic, for transportation, through use of electricity. But as some of you are aware, we've had some fairly large fires the last couple of years. And so the lines at the bottom give you some idea recently of how much carbon dioxide has gone in simply because of the fires. I mean, it's over 400 million tons at this point for the fires that took place in Australia. So the real reason for climate change is basically the way we think. Okay? We don't think in systems, we think in little pieces and parts, and as a result of that, we don't never have the full picture of what we're actually doing or causing to have happen. We also need to keep in mind that we're sort of a unique species. We're the only species that makes trash. We're the only species that doesn't live on readily available resources. Okay? It's dark, so you don't actually have to raise your hands, but I know some of you had coffee this morning, okay? But we don't do coffee here, okay? Then how many of us actually think about what does it take to get that coffee grown and ground and shipped to us and all that other kind of stuff? What's that footprint, okay? Where do things come from? Where do things go? We sort of knocked curiosity out of education for the last several years, so we want everybody to take standardized tests. And as a result, we're not asking the kind of questions we used to ask. Okay? So we're trying to sort of put ourselves back in context here. That's going on. So just to show you sort of differences in heat. This is a NASA image for heat. This was back in 1884, and the blue colors mean cool, and the yellows, oranges, and stuff like that mean hot. And I'm red-green colorblind, so basically, if I can see the color, it's cool, and if I can't see the color, it's hot. Okay, and so this is 2013. I mean, you know, we have changed the world a tremendous amount. Okay. And so, as I said before, you know, we've got about 413 parts per million of carbon dioxide in the atmosphere. The last time we saw that was during the Pleistocene. Okay? We're about, at this point, some 10 to 20 meters short on sea level rise. There's a lag in how long it takes for the ice to melt as you start bringing up this heat. But as later on, as Harold Wainless is talking about sea level rise and stuff like that, just keep in mind that, you know, we're already at a carbon dioxide level that says if we just stop here, then you got to expect the ocean to rise for another 30 to 60 feet. Okay, which we don't want, but I think that would be obvious. So climate change itself, it changes everything. It changes everything everywhere at the same time and interactively. So we have changed lots of things. We've changed the ocean. We've heated the ocean up significantly. About 90% of the heat that's been generated by our greenhouse gases has been stored in the ocean. We've altered the first 700 meters of temperature in the ocean's depth. And the heating is not constant. We're actually doing it 4 times faster now than we were earlier in the last century. We're also creating more storms around the world, and larger storms because of the heat that's available. We are melting ice at the poles and on glaciers in ways that we've never seen before. The planet may have seen them, but we haven't seen them because we weren't around at that time. So it's hard to make predictions because we actually don't know how the ice is going to melt. Right now, we know that it's melting on the top, it's melting on the bottom, it's melting on the sides, and it's melting in the center. And how much of that is going to change how fast these glaciers move and shrink is quite unknown. But we do know that the speed of glacier melt is on a constant increase at the moment. So we needed to keep in mind that most of this stuff is in the negative as far as stopping. And it's not passively reversible. If we stop doing anything right now, we still have enough heat to cause a lot of changes in the system. So, boom. And we also have to be careful with the data because as we gather it, sometimes some things get missed. NASA done a very good survey of what they thought was going to be the sea level rise in parts of the world, and then found out that their satellite technology was not looking actually at where the land was. In some areas where you had very dense vegetation along the coastline, they were actually reading the top of like the mangroves and stuff, as opposed to where the land actually was. And so that data got rescanned. And basically we are in the process of putting an additional 630 million people at risk of sea level rise. We're changing the ocean currents, their speed, their direction, and where they're going. We are changing the acid level in the ocean. It's now 30% more acidic than it was before. As you increase the temperature, you also deoxygenate the water, the ocean. So ocean does not have the same amount of oxygen that it used to have. This changes who can live where. And the other thing, other than that, we're also changing the salinity. So we're changing the entire ecosystem, which determines what form of life can live where. So when we talk about the fact that we're creating dead zones, what we're really doing is creating places where the stuff we like, the fish we like, the crabs, the shrimp, those kinds of things, don't have the oxygen or the temperatures that they can survive there. We're now creating zones that are very good for different types of bacteria and algae, but not for the stuff that we like. And that's why we call it a dead zone. And the changes are just continuing. I mean, there is a plan now that instead of just looking at emissions, is to look at heat loading. So water is not a greenhouse gas, but it's a huge heat trapper. And the more you warm things up, the more heat that can be held and generated. And so the question becomes, how much heat are we actually going to generate per area? And the thing about this map, this chart that was done by the IPCC several years ago, is that we're here, okay? We are already way ahead of the curves, okay? We're not following any of the projections. What we've changed in the atmosphere is happening much faster than anybody thought it possibly could. And so what you're going to see with issues of sea level rise and those projections is that they're not static. They're changing all the time. And unfortunately for us, their change is to go faster and to go higher. Nobody is projecting that there's going to be less sea level rise. It's all about how much more. Okay. And as we do this, sorry, wrong figure. There we go. So here in Sarasota, Manatee, right now, peak is a little bit over 8.5 feet as opposed to being below 7 feet in the previous chart, okay? And the rate of change is changing. So it's not, there's change, and then there's rate of change, and it's exponential, not linear, okay? Let's see who we got. Oh, yeah. And as you raise sea level, that pushes more salt water in, which causes our freshwater lens to shrink or to become contaminated. So it's easier for us to lose freshwater supplies or damage freshwater supplies because we're letting more salt water into those systems. Okay? And ocean isn't the only place we're making changes. We're making it on land. As you increase temperature by 1 degree Celsius, you increase the amount of water vapor in the air by 7%. So we're taking water from land and from surface water, and we're putting it into the air. We are completely changing the water cycle of the planet. This is where we're getting the changes in whether or not you're going to have drought or rainfall or water bombs, rain bombs, like you see in that last picture. Okay? And right now, for example, we're making the humidity so high in places, we already know that the amount of work that can be done outside has been reduced by 10%, and by 2050, it's going to be reduced by at least 20%, and probably even more than that. Okay? And also keep in mind that even in our best intentions with the Paris Accords, where everybody talked to you and announced on the news that we're going to try to keep temperature at 2 degrees Celsius rise or less. We really wanted to go for 1.5. The promises everybody made basically were for a 3.5 or 6.3 degrees Fahrenheit rise. Okay? So when everybody's telling you they're going to go for 2, they were actually going for 3.5. Okay? And so the climate accords really aren't going to do us much good at this point. And we already have places in the United States where we have exceeded 2 degrees of warming in our area. And locally, we're going to see a real shift here with the increase in humidity and increase in temperature, where we're going to go from about 5 days with a heat index over 105 to, by mid-century, somewhere around 86 for the Sarasota area, and up to about 135, about 4 months at the end of this century, if we keep on the track that we are on, and everything we're doing policy-wise is keeping us on the track that we are currently on. We also see with this a change in other aspects. The changes in weather and drought cycles, rain cycles, is causing us to see more fires. We have changed the Indian dipole, the circulation, much like the El Nino, but this one's in the Indian Ocean. And so what we've had for the last several years in the Indian Ocean is wetter and warmer on the African side, and much cooler and drier over on the Australian side. And the result of that, of course, is that we've now created a habitat for a plague of locusts in East Africa. That's what you're seeing here. And that same airflow is what has created the opportunity for the massive fires in Australia. We are also at this point, because water cycles, heat cycles, wind patterns are all out of sync, we are completely changing the phenology of when things happen in the environment. When should birds nest relative to when their food is available is now out of sync in many parts of the United States. We have a pignut hickory on our campus near where I park, and I feel very sorry for this tree because we have these warm spells and then we get a cold snap. We have warm spells, we get a cold snap. And this poor tree for the last couple of years has gone through like 4 years of cycles in a year. I'm leafing out, I'm breeding, oh, I'm dying. And it's just because the weather patterns aren't stable as they used to be, and not at all in terms of pignut hickories. So again, it's just all changing much faster than we had thought. And when I grew up, when most of you grew up, it was reasonable to think that the weather you had as a child would be the weather you would see in old age. For my daughter, that is not the case at all. She knows the weather she's seeing now is the best weather she's going to see, and it's going to be completely different, in another 20 years. To the extent that one of the issues that we're now dealing with and talking about is climate separation. So the average high temperature at the moment in Sarasota, annual high, is about 82 degrees Fahrenheit. So that's the high now. By later this century, somewhere around 2045, 2050, we will be at a point, we stay on this current track, where the average low temperature for Sarasota will be higher than 82 degrees Fahrenheit, okay? That changes everything. That changes what you can grow and if you can grow things here. Boom. We're also seeing huge shifts in health impacts. Right now, 90% of the world is breathing polluted air. Before those greenhouse gases get high enough up in the atmosphere to trap heat, they go through this phase of just being air pollution. Okay? And so we're seeing some real major impacts there. And to the extent that climate change is becoming sort of the long-term health concern by doctors for children. I said it impacts everything. We're also seeing huge impacts in the economics. Okay? Every year at the World Economic Forum, the world's economists come out with a list of the 5 most things that are likely to happen that will be disruptive to the environment, to the economy, and the 5 things that are put the economy at greatest risk. Okay? This year, for the first time ever, the likelihood component was all of one category. It was all about the environment. This is what economists are now worried about. Okay? And so I don't have to argue this stuff or talk about this stuff in terms of the environment anymore. I can do it in health and I can do it in economics. When the world economists start being concerned about the environment, everybody's going to start listening to that. And if you consider that water crisis is an environmental issue, not just a social issue, then even in the greatest risks, impact is the climate dominates there. And I also thought it was very intriguing that not taking action on climate, not coming up with good policies, was considered to be a greater risk, to have greater damage than weapons of mass destruction. Okay? This is a real sort of shift. I mean, most of the time, we operate in the world of the economy. Okay? And we don't really make ourselves aware of the resources behind that. Okay? I mean, all the stuff we buy is already finished, but who knows what it took to make any of the cloth that we're using or shipping it around. And this is critical to keep in mind because the issue is, since the economy is based on environmental resources, the only way to have a long-term economy is to have a healthy long-term environment. Okay? And so we need to figure out how to do both of these things. And to give you some idea of how we are working with our, or dealing with this intellectual disconnect, JP Morgan Bank, which is the largest supporter and funder of fossil fuels, in an internal report recently came out with little statements like, we cannot rule out catastrophic outcomes where human life as we know it is threatened, and that something will have to change at some point if the human race is going to survive. But let's not get that in the way of quarterly profits. Okay? And one of my pet peeves is this one, which is the fact that we've been looking for a Northwest Passage for a couple hundred years, and we've now melted one into existence. Okay? And so there are a lot of people who think this is a great idea because now we can move trade goods and stuff back and forth even faster through the Arctic. But the issue is we're not supposed to melt the Arctic. Okay? And at some point there's going to be a price to pay for having sunk Santa's workshop and drowned the elves and the reindeer. That is going to come home to roost at some point. And the sooner we get Santa back some ice, the better off we're all going to be. So, and we use a lot of resources. This is a staggering figure, was that last year we had to mine or harvest 110 billion tons of raw natural materials to make the stuff that we used just in that 1 year. Okay? I mean, when I last checked, it took 1.5 tons of raw material to make a laptop computer. Okay? If you include what you use in the computer and the mining waste. And so one of the things I ask my design students is, what do you think you're doing? Are you designing 1.5 tons of waste and you have a computer left over when you're done? Or are you actually trying to design a computer, but you're generating all this waste? And why are things so disproportionate with each other? And again, I mean, this idea that we have this disconnect and don't think about a lot of things, I mean, you can sort of see very quickly here. We take machines that use carbon fuels, releasing carbon dioxide into the environment, to rip out the things that are storing carbon dioxide from the environment. Then we burn the things that were storing the carbon dioxide, so we release the carbon dioxide back into the environment so that we can create places that have no surface vegetation and no soil life, so we're just making dirt that blows away. We ought to be able to do something smarter than that. So it said, global disaster. We got a global disaster on our hands if we keep harvesting resources, at this scale. And to give you some idea, the global footprint network tracks our use of resources on an annual basis. And essentially, since 1972, we have been exceeding the Earth's capacity to support ourselves. So this line is Earth Overshoot Day, the day in which we have surpassed the Earth's capability to supply our resources for a year. In 2019, we passed that date on the 29th of July, and we're on track to even have it earlier in July this year at the moment. Okay. Again, because we think of things separately, we have to redo everything. And we have to redo the food system because right now we're looking at growing a population to nearly 10 billion people by 2050. And horizontal, crop-based industrial farming based on petrochemicals and irrigation doesn't have the capacity to feed that many people. Okay? We're going to have to shift farming to something that is more diet-based, that uses living soil as the source of the nutrients to be able to have a ghost of a chance of meeting that. Otherwise, we're just growing more problems, more devastation for people. Okay? And in the 2018 World Economic Forum report, they talked about the fact that when risk cascades to a complex system, the danger is not of incremental change, but of runaway collapse or abrupt transition to a new suboptimal low. Once things really start to break, they're going to break really fast, they're going to break really hard, and they're going to break much faster than we thought and much faster than we had the capability to restore them. So the issue is not to let them break. Okay? The other sort of key slide in here is that it doesn't matter who you're talking to, whether it's bankers, whether it's the UN. People in policy, large international policy are now talking about the fact that this is a real risk that's going to be come back and haunt us big time. And so I want to make it clear here, because this is something I deal with many of my students. First, my daughter did not cause climate change, okay? Nor did any of my students, nor did our children or our grandchildren cause climate change. This is on us. This is my generation, my parents' generation, my grandparents' generation, because the big changes that we've had have basically come since the 50s. Okay? Before then, there weren't enough of us around to cause this much problem, but now with a population of 7.7 billion people, we can cause lots of problems fairly quickly. And because we're so detached in our thinking about the environment and about other people in other places, we don't really see the cumulative harm that's going on. And so what are we going to do about this? Now, I know for one of the people concerned about climate anxiety and the separation in how a lot of adults look at it, like it's something that's sort of off in the future and we've got some time, to how college students look at it, which is they're not going to die from old age. They're going to die from climate change. This is a real huge shift in what you see and what you think. And I've often been told that I can be relatively depressing when talking about climate change. But I'm an optimist in the Madeleine Albright school, which is I am an optimist, but I worry a lot. And the question becomes, what's the happy ending to this story? Okay? I'm often told, leave them with hope. Okay? And I'm going like, are you nuts? This story has no happy ending. This thing doesn't play out well. This story is about the type of damage we are going to do. We're basically looking, if we keep on this track, to collapsing civilization as we know it, probably by 2100. We are looking at doing climate genocide of all other species on the planet. We're looking at doing climate suicide for ourselves if we keep on this track. This story does not have a happy ending, okay? Now, if you're asking me whether or not this could have a happy ending, the answer is if we completely change the story. We can start from here and make a happy ongoing system. But it means all we have to do is change everything that we're currently doing and how we're doing it. It is absolutely that simple, okay? Which is why I've waiting to buy an SUV until David was through asking those questions earlier. And we do have to sort of get the fundamentals right. And again, it's dark, so I can't see if you raise your hands or not here. But how many of you have seen a sunrise? Okay? And how many of you have seen a sunset? Okay? And the answer is none of us have. Okay? I mean, seeing a sunrise and sunset is about if the universe revolved around the Earth. It doesn't. Okay? We revolve around the sun. Okay? So we got to get the fundamentals right. Okay? We can't use models from the past. We don't have any that work. And we've designed most of the stuff in the last several years that doesn't give us a good result. Okay? So it is about changing everything we're doing. We're going to have to change, as I said, the way we use fuels and the modality of transportation. It's not that we can't do things. We just got to do it all differently. Okay? That's where we are. We've got to change how we do agriculture. We've got to change how we do electrical generation and the distribution systems. Mike Jackson's going to talk about that. We need to do full cost and true cost accounting. We can't have externalities in business anymore. We can't have pollution, whether it's molecular or physical. That stuff can't happen. It all has to go back into resupporting life on this planet. David will talk about that when he gives his talk, just as Harold's going to further explain the sea level rise for you. And we're also going to have to come to grips with population. Okay? It took us the better part of 200,000 years to get to 2.5 billion people in 1950. In the 100 years between 1950 and 2050, we're going to be adding 7.3 billion people. Oh, it went the other way. Where are you? Boom, boom. Yeah. Okay. Boom. There we go. We're going to be adding 7.3 billion. When you accelerate the rate of population growth that much, you have to completely redo and rethink everything. Because we're just moving at a pace that was never designed for the scope of what we're doing. And we also need to keep in mind that, again, the economy and natural resources are linked. In 2013, the World Bank did an estimate of what is the planet's gross domestic product. How much money is the planetary economy worth? And the kicker here is that the blue, the $125 trillion of economy, 63% of it is nature. This is nature cleaning air, nature cleaning water, insects pollinating food. Okay? The part we talk about on the nightly news, is just a sliver of the part over here that's only 37% of the whole economic process. So in economics terms, this is externalities. And so it doesn't get costed in anywhere. Now we know we have to cost it in. And we also have to get the order of primary importance right. Environment first. Okay? Take care of the ship. Doing oceanographic work, the issue, everybody went out with the project that they really wanted to do. But the question was, were you taking care of the ship? Because if you didn't take care of the ship, you weren't getting home. And so you had to take care of the basic things first, the planet, and then the human interactions, and then the economy, which is basically value systems defined by society. Okay? We look at the world in completely the reverse order. I look at what people are talking about with the COVID-19 virus, and how panicked the markets are, how panicked people are. I can appreciate that, but yes, I know I'm over time. But this is the big game. You want to survive COVID so we can die from heat, and malnutrition. This is the game that we have to rechange and realign ourselves with. So we need to understand that everything is actually connected to everything else. And as David said, we're not trying to save the planet. We're just trying to save ourselves. We're trying to stay in the game as long as we can. But the way we're playing right now, we end pretty fast. Okay? And one of the big kickers in here is that we have to not confuse knowing with what to do with actually doing it. Okay? I know as a kid, and you broke something, somebody else did that. Okay? And with the environment, a lot of people are thinking that somebody else is going to help, that somebody else is going to pick up the trash, or somebody else is going to do something. Look to the person next to you. Everybody is somebody else's somebody else. Okay? It's us. We all have to be actively engaged in this process. The good thing is that we know how to do all the key stuff that we need to do. We're just not doing it at scale for it to make a real difference yet. I mean, we know how to make energy positive buildings. We know how to do electric transportation. We know how to grow vertically indoor food that's diet-based, that's local, that's organic, that is more nutritious. We know how to do how to capture, conserve, clean, and recirculate water. I mean, we can do that biologically. We can do that with plants. I mean, it's all possible. We just have to now bring it up to scale. And as we do, we will certainly find new ways to do it and new ways to improve it. We have to find ways to take plastic and turn that into a non-pollutant, but to turn it into, take the stuff we've already made and turn that into something functional while we figure out how not to make the new stuff anymore. Okay? And as Bogo said, we are surrounded by insurmountable opportunities. This is fixable, but not if we stay with the old story. Only if we switch to the new one. Okay? And functionally, we're it. We're the ones we've been waiting for to make that change. And it's time that we did it. So thank you very much.